Welcome to the SmartKeys podcast.
Thanks for having me. I'm really excited to get into this one.
Yeah, me too.
Yeah.
It used to be that when a business needed to scale up its technology, there was this comforting expectation of precision.
Oh, absolutely.
You needed more computing power, so you bought a physical server, you plugged it into a rack, you depreciated it over 5 years, and you knew exactly what it cost. It was just a fixed, predictable line item sitting neatly on a spreadsheet.
Right. That was the era of capital expenditures. You write the check, you physically own the hardware, and the financial risk is, well, it's entirely bounded by what you literally purchase.
Exactly. But then you step into the world of modern cloud computing, and suddenly that predictable spreadsheet is just completely torn to shreds.
Yeah, it's gone.
We're looking at a financial landscape today that is genuinely terrifying for a lot of companies. You run these incredible cloud systems that allow you to, scale infinitely up and down on demand, but they come with a massive catch.
Yep, the variable bills.
Right? These meter-driven bills that can result in massive, six-figure financial surprises at the end of the month.
It's a fundamental shift in how businesses consume resources, really. I mean, the very flexibility that allows an engineering team to innovate quickly and, say, launch features overnight, that's exactly what makes the resulting spending so opaque to the rest of the company.
Because it's too fast to track.
Exactly. The friction of traditional procurement is just gone, and so are the guardrails.
Which is really the core tension we are tackling today. Our mission for this deep dive is to explore how to turn those unpredictable, meter-driven bills into actionable data.
Right.
We want to help you, whether you're sitting in the engineering department, product management, or the CFO's office. Shift your cloud spend from being this terrifying black box expense into a driver of actual business value.
Which is so crucial right now.
It really is.
Yes.
And we are pulling our insights today from a highly comprehensive framework on FinOps best practices written by Felix Römer, who is the founder of SmartKeys.org.
And honestly, treating this as a comprehensive resource is the right approach. The insights in this framework make it very clear that managing cloud spend is, it's no longer just an IT issue.
Right, it's bigger than that.
Much bigger. It is a strategic imperative for any modern professional trying to keep their business competitive.
Okay, let's unpack this, because before we can optimize the underlying technology, Felix points out something really crucial.
Yeah, the culture piece.
Exactly. We actually have to fix the communication gap between the people using the tech. We have to address the human element before we even touch the code.
That is the necessary starting point, for sure. The underlying problem generating those massive bills is it's a complete lack of visibility caused by how fluid public cloud platforms actually are.
How so?
Well, think about it from a workflow perspective. If an engineer needs more compute power to test a new machine learning model, they don't, submit a purchase request to finance and wait 3 weeks.
Right, they'd never get anything done.
Exactly. They just spin it up with a few lines of code. That speed is phenomenal for the business, obviously, but it completely bypasses traditional budget oversight.
And because it is so frictionless to spin those resources up, it is equally easy to just forget to spin them down.
Oh, happens all the time.
The framework specifically highlights things like unattached elastic IPs, orphaned EBS snapshots, and paused Redshift clusters. For anyone who isn't elbow deep in AWS all day, what are we actually talking about here?
We're basically talking about digital hoarding.
Digital hoarding, I like that.
Let's break those down. An EBS snapshot is essentially a backup of a cloud hard drive. Often, an engineer will delete a virtual server they no longer need, but completely forget to delete the backup drive attached to it.
Oh, wow. So it just sits there.
Yep. So you are paying monthly storage fees for a ghost drive forever. Unattached elastic IPs are static web addresses that you reserved but aren't actually routing traffic to.
It's claiming real estate.
Exactly. And Redshift clusters are these massive data warehousing environments. You might pause one thinking, oh, I'm saving money, but the cloud provider is still charging you to hold that space.
So these are assets generating zero value for your customer, but the meter is just spinning 2147.
Spot on.
It makes me think of living in a massive mansion with 10 roommates. Every single person has access to the thermostat, the water, the electricity, and everyone just leaves the lights on and the water running because the utility bill just goes to, the house.
That's a perfect analogy.
Nobody knows who specifically left the hallway light on for 3 months, so there is zero individual accountability. But here's the friction I see. If I'm a developer, my job is to make sure the application doesn't crash on launch day. I am judged on speed and uptime.
Right.
But how do you actually make engineers care about the finance team's budget without slowing down their workflow? Aren't you just asking them to risk an outage?
And that tension is exactly why traditional budgeting fails in the cloud. You can't just tell engineers to spend less.
Hmm.
It doesn't translate to their daily work at all.
So what's the fix?
The framework solution to this is establishing a Cloud Center of Excellence, or CCOE.
A cloud center of excellence.
Yeah.
I mean, that sounds like a committee that schedules meetings to talk about scheduling other meetings.
Yeah, it totally can become that if implemented poorly. But by design, it should be a really lean, cross-functional advisory group. You pull in a lead from finance, a lead from engineering, and a lead from product.
Okay, so a representative from each camp.
Right. And their job isn't to approve every single server request. Their job is to agree on shared cloud goals and establish a standardized language. They basically translate financial goals into engineering guardrails.
So they are the ones building the system to figure out who left the lights on in that mansion.
Exactly. And they do that by defining ownership through targeted reporting, specifically, utilizing showback and chargeback models.
Okay, walk me through how those actually work in practice.
So, a showback report is essentially an informational dashboard. It maps cloud usage directly to the team that consumed it.
Okay.
So instead of finance just looking at a single AWS bill for, say, $1 million, they send a showback report to the marketing tech team that says, hey, your specific recommendation engine cost us $40,000 this month.
So it creates that missing visibility.
Exactly. A chargeback takes it a step further and actually deducts that $40,000 from the marketing department's internal budget.
I see. So the showback is the awareness piece, and the chargeback is the actual financial consequence.
Yep, exactly.
But either way, it completely removes the anonymity. If the marketing tech team suddenly sees that leaving their test servers running over the weekend costs them like a quarter of their monthly budget, they're going to write a script to shut those servers down on Friday afternoons.
That is the behavioral psychology at play right there. Visibility inherently changes behavior.
Yeah, that makes a lot of sense.
When you provide role-specific views, meaning finance gets clear cost forecasts, and product teams see exactly what a specific feature costs to run, you eliminate the abstract debates. Engineers naturally start making smarter trade-offs between speed and cost because they actually have the data to do so.
Okay, so that handles the culture side. The CCOE is running, teams are looking at their showback dashboards, and the anonymity is gone. But how do we actually fix the code so the waste stops happening?
Right, the technical side.
Yeah, once a team realizes they are overspending, what are the actual technical mechanisms to bring that bill down?
The immediate tactical step is continuous right-sizing. This just means aligning the compute power and storage you are renting with the actual workload demands of your application.
Because developers naturally practice defensive engineering, right? Like, if you aren't completely sure how much traffic a new product launch will generate, you provision the extra large server just to be safe.
Exactly. You over-provision to mitigate risk. But the problem is that you end up utilizing maybe 10% of that server's capacity while paying for 100%.
Ouch.
Yeah. The framework emphasizes that you cannot fix this manually. You have to monitor CPU, memory, and I/O metrics to understand real utilization. And then you integrate that right-sizing logic directly into your infrastructure as code.
Meaning the automated assembly lines where code gets pushed to the live app?
Yeah.
Things like CI/CD pipelines?
Yes, or tools like Terraform and CloudFormation, which are essentially scripts that automatically build your servers based on predefined rules.
Got it.
If you bake right-sizing into those scripts, new instances are forced to start efficiently from the very beginning. You take the human guesswork completely out of it.
And it goes even further than just processing power, doesn't it? Because data storage is a massive hidden cost.
Oh, storage is notoriously mismanaged. The strategy here relies on lifecycle policies and tiered storage. Think of a service like S3 intelligent tiering.
How does that work?
Well, if you have an application generating terabytes of log files, you don't know how often an auditor might need to pull those files up.
Probably never, but you have to keep them just in case.
No. Right. So instead of paying premium rates to keep those files on high speed, instantly accessible storage, intelligent tiering just monitors the access patterns.
Okay.
If a file isn't touched for 30 days, it automatically moves it to a slightly slower, cheaper storage tier. If it's untouched for 90 days, it moves it to a deep archive tier, which costs literally pennies. It completely automates the cost reduction of data hoarding.
Here's where it gets really interesting, though. Beyond just cleaning up the engineering waste, the framework digs into the procurement levers. It mentions that businesses can unlock up to 70% off their standard on-demand cloud rates.
Yeah, it's a huge lever.
But that sounds massive. Why would cloud providers like Amazon or Google offer such deep discounts?
Because public cloud providers are ultimately managing physical hardware. They have massive data centers and they need to plan their physical capacity.
Right, they have real-world constraints.
Exactly. If a business is willing to commit to a baseline level of usage over a 1-year or 3-year term, it guarantees revenue for the cloud provider and allows them to manage their physical server racks much more efficiently. In exchange for that predictability, they reward you with severe discounts.
That makes perfect sense. The framework outlines two primary vehicles for this: savings plans and reserved instances. How should a business choose between the two?
It really comes down to how predictable your architecture is. Savings plans are broader. You are essentially committing to a specific dollar amount of spend per hour.
Okay.
The advantage is flexibility. If you decide halfway through the year to move your computing to a different geographic region or, switch to an entirely different family of processors, the savings plan discount still applies as long as you hit that hourly spend commitment.
So it is a financial commitment, not a technical one. Reserved instances, then, must be more rigid.
They are. Reserved instances are for steady, highly predictable baseloads. You are locking in a specific server family in a specific data center.
No changing your mind.
Right. And because you are giving the cloud provider much tighter parameters, the discounts on reserved instances can sometimes be even deeper.
But wait, this brings up a massive risk. If I am a finance leader and I see a 70% discount, my instinct is to lock that in immediately.
Oh, of course.
But what if I commit to a 3-year reserved instance for a massive database server, and then 6 months later, my engineering team decides to refactor the app, and they don't even need that server anymore?
What's fascinating here is that you've just identified the most common FinOps trap. Committing to the wrong plan just locks in wasted spend.
Wow.
You are getting a 70% discount on a server you didn't even need. It's like signing a 3-year lease for a massive moving truck because you got a great monthly rate when all you actually need to do is commute to the grocery store.
You're just subsidizing your own inefficiency at that point.
Which is why the order of operations is non-negotiable. You must right-size first. You clean up the architecture, you get your servers running efficiently, and then you forecast your demand and buy commitments based on that optimized state.
Makes sense.
Buying discounts before optimizing your infrastructure is just making your waste permanent. As the framework notes, catch spikes early. Alerts for runaway queries or scaling bugs save you from huge overspend.
Okay, so right-sizing VMs and buying commitments makes a ton of sense for traditional applications. But modern engineering is moving incredibly fast.
Yeah, it's a different world now.
We aren't just spinning up a few predictable virtual machines anymore. We are dealing with orchestration platforms like Kubernetes, where an application is broken down into hundreds of tiny microservices that spin up, do a job, and terminate seconds later.
Exactly.
How on earth do you track costs when the environment is that fluid?
Kubernetes is where traditional cost allocation goes to die. Oh, yeah. To understand why, you have to look at how it operates. Imagine a massive commercial restaurant kitchen. The kitchen has 50 stove burners. That is your Kubernetes pool of shared computing resources.
Okay, I'm picturing it.
Now you have 20 different chefs representing your different product applications, constantly running in and out using whichever burners are available for a few minutes at a time to cook their dishes.
And at the end of the month, the finance team just gets one massive gas bill for the entire kitchen.
Exactly.
They have absolutely no idea if the appetizer station or the grill use the most gas, so they can't accurately price the menu items.
That is the perfect analogy. The cloud provider's invoice just says Kubernetes cluster. It doesn't tell you which microservice consumed the CPU.
So how do you fix it?
To fix this, accurate cost allocation has to start from inside the cluster itself. Engineering teams must implement namespaces and enforce consistent tagging conventions.
So putting a name tag on every single pan in that kitchen?
Essentially, yes. You tag the owner, the product, and the environment directly into the PIM. When a microservice spins up, those tags allow your FinOps software to track exactly how much of the underlying infrastructure it consumed and then route that data back to the showback reports we discussed earlier.
But even if we tag everything perfectly, there is still the issue of infinite scaling, right?
Oh, for sure.
Kubernetes is designed to auto-scale based on traffic. If a marketing campaign goes viral, the system will just keep spinning up new resources to handle the load. That is fantastic for the user experience. But couldn't that technically bankrupt the company if the cloud bill scales out of control?
It absolutely can, which is why automated guardrails are mandatory in these environments. The framework details two critical mechanisms for this. The first is pod autoscaling, both horizontal and vertical.
What does that do?
This ensures that the system is scaling intelligently. It evaluates real-time metrics so it only adds resources when the demand genuinely requires it, rather than just blindly spinning up massive, oversized instances at the first sign of traffic.
And the second mechanism.
The enforcement of those rules through tools like Open Policy Agent. Open Policy Agent acts as an automated bouncer for your infrastructure.
How does that actually work mechanically, though? How does it stop a server from spinning up?
It intercepts the deployment request in real time. Let's say an engineer accidentally writes a script that requests the deployment of an incredibly expensive, high-performance computing cluster in a premium geographic region.
Okay.
Before the cloud provider even attempts to build it, Open Policy Agent checks that request against a pre-approved list of rules. It sees that the request violates the budget policy, and it simply rejects the code execution.
Wow.
The deployment fails safely. It stops the financial bleeding before the cut even happens.
That is brilliant. It completely automates the governance. And I imagine this need for centralized control becomes even more critical when a company is operating a multi-cloud strategy, using AWS for their databases, Azure for their enterprise tools, and Google Cloud for machine learning.
Multi-cloud is the reality for most enterprise businesses now, and it is a logistical nightmare for finance teams if they rely solely on native tools.
You mean the free dashboards built into the platforms like AWS Cost Explorer or Azure Cost Management?
Right. Those native dashboards are great starting points. They give you immediate visibility into that specific ecosystem, but AWS Cost Explorer doesn't talk to Google Cloud.
Ah, I see.
So if a finance team wants to see the total cost of a product that stretches across both platforms, they have to export CSV files from both dashboards and manually stitch them together in Excel. It is prone to error and inherently backward-looking.
So they need a third-party hub to sit on top of everything.
You must complement native tools with a centralized cost intelligence platform. That central hub ingests the billing data from AWS, Azure, and Kubernetes simultaneously. It normalizes the data, creates a single source of truth, and fires off real-time alerts across the whole organization if budget thresholds are nearing.
Okay, let's step back and look at everything we've built here. We've established a cross-functional culture, we've implemented tactical right-sizing, we've optimized our procurement contracts, and we've deployed centralized hubs to monitor our Kubernetes clusters.
We've covered a lot of ground.
We really have.
Yeah.
But tracking every single penny across multiple clouds is totally useless if the data doesn't tell us if the business is actually fundamentally healthy.
Exactly.
Which brings us to the ultimate strategic metric of this entire framework, unit economics. So what does this all mean? Let me throw a real-world scenario at you.
Sure, let's hear it.
I'm a CEO. I look at our new centralized dashboard, and I see that our total cloud spend went up 25% this quarter. On paper, that looks like a massive FinOps failure. Our bill is getting worse.
Yeah.
But what if our rising cloud bill isn't actually a bad thing?
Reframing that exact scenario is the entire point of unit economics. Judging the health of your infrastructure by looking at the raw total spend is a complete trap. Yes. If your cloud bill went up 25%, but the volume of transactions on your platform went up 50% in that same period, your infrastructure didn't fail. It actually became significantly more efficient. You are acquiring customer value at a more profitable margin.
So you have to stop looking at the aggregate dollar amount and start looking at the ratio of cost to business value.
If we connect this to the bigger picture, modern professionals have to translate cloud bills into business metrics. Depending on your industry, you need to track the cost per customer, the cost per transaction, or the cost per session.
Give me an example of how a company would apply that.
Think about a major video streaming service. Their cloud bill is astronomical, but they don't judge engineering success on whether the total bill went down. They judge it on the cost per hour of video streamed.
Oh, that makes perfect sense.
Right. If an engineering team optimizes the video transcoding algorithm and the cost to stream 1 hour of video drops from 2 cents to 1 cent, that is a massive victory, even if the total monthly cloud bill goes up because millions of new users subscribed.
That completely changes the boardroom conversation. You are no longer saying engineering needs to cut $50,000 from the server budget. You are saying our cost per checkout transaction drifted upward this week. we need to investigate which code deployment caused that friction.
And it makes forecasting incredibly precise. If the product team is planning a massive new feature launch, finance and engineering don't have to guess what the server budget should be.
They already know.
Exactly. They look at the historical cost per transaction, forecast the expected volume of the new feature, and they know exactly what the cloud bill should reflect.
And it allows them to prioritize their actual daily work. If the unit cost of a specific feature starts eroding the profit margin, the engineering team knows they need to pause building new features and prioritize optimizing that existing code in their backlog.
As the framework summarizes so perfectly, when unit economics are clear, acceptable cost increases follow revenue inefficiency becomes visible and actionable. It aligns the code, the tooling, and the budgets into one unified business goal.
Inefficiency becomes visible and actionable. That really is the crux of this entire deep dive. It takes the emotion and the friction out of the conversation.
It really does.
Which leaves us with a really fascinating way to look at the future of software development. I want to offer a final thought for you listening today. Think about how we traditionally measure an engineer's success. We look at the speed of their delivery, the lack of bugs, the uptime of their service.
Sure, the standard metrics.
But moving forward, what if we stop viewing cloud costs as just a monthly IT bill handled by finance and started treating financial efficiency as a core metric of the code's quality itself?
Wow, it elevates the role of the engineer to a business strategist.
It changes everything. Good engineering isn't just about speed and uptime anymore. It is about unit profitability. Writing code that auto-scales intelligently, that gracefully tears down idle resources, that utilizes intelligent storage tiers, that is the mark of an elite modern engineer.
Absolutely.
Because if your code works perfectly, but it destroys the profit margin on every transaction, it isn't actually good code. Mastering FinOps means you aren't just writing software, you are actively architecting the financial success of your company. It is finally taking that massive mansion with 10 roommates and giving everyone the data they need to keep the whole house running efficiently.
It proves that when you bridge the gap between finance and engineering, the entire business moves faster.
It absolutely does. I want to explicitly thank you for tuning into the SmartKeys podcast. We really appreciate you spending your time with us, exploring the strategies that are shaping the future of business efficiency.
There's a lot to navigate in the cloud, but applying these principles provides a measurable competitive edge.
Without a doubt. If you want to stay ahead of the curve on the future of work, SaaS innovations, and strategic engineering, make sure you hit that subscribe button. And please do yourself a favor and read the full, comprehensive article by Felix Römer to get all the granular technical details we discussed today. We have put the link to the original SmartKeys article right in the show notes for you. Until next time, keep optimizing, keep questioning the black box, and we will see you on the next deep dive.